All right, good morning. Happy Wednesday. P7 is due tonight, and I'll take questions that you might have on that. Also, we're going to take a P7 test exam on Friday morning at 8 a.m. And today, we're going to look at some word problems. You know, students always ask me, when are we ever going to use this in life? And I think that's a really good question. Like, why do anything if we're not going to use it in real life? The thing is with mathematics, it takes some math, a lot of math, before you actually see the applications in a complicated real life situation. So you have to get to a certain point. You have to get to a certain point before you actually see, you know, the application in real life. So today I picked some problems from P.8 that do apply to real life, but just know that Algebra 2, Precalculus, those things are part of a bigger picture, and those are higher level math classes, which you haven't taken yet, where you're going to actually see applications. So. All right, so let's just start. We're on a shorter day today. The class is from 9:30 to 10:15. Rather than the 80 minutes. Does anybody want to ask me any questions about P7? There are a whole lot of things you have to know.
I actually didn't understand 23 from P7.
Okay.
Yeah, if you can like help me out with like maybe doing like that specific problem or something.
Okay. All right. Put the simple binomials in parentheses. That's the best advice I could give you. Am I writing down the right problem? Minus 1 over x minus 1. And then what's the rest of this? Equals 2x over 2x squared? 2x over x squared minus 1. Okay. Okay, I'm not going to put that one in parentheses because that's not a simple binomial. That could be factored. Now, what I try to do, you guys, is I try to, when I'm given a problem, I try to just look, before I start trying to do anything, I just look at it to see what type of problem I have. You know, is it a problem that I want to factor? I have to know the, 7 factor methods. Is it a problem we're going to use square roots? We have to isolate the square roots. So basically, the type of problem that I have depends on the approach I'm going to take. So when I look at this, I'm going to read the directions, and it says you're going to do 2 things. You're going to write an excluded value, and you're going to solve it. Now, the question is, what is this thing? And this is not linear. If it was linear, it'd be so easy because all we do is solve for x. But this is a rational equation because of the variables in the denominator. So the first thing that's bothering me is all these fractions. So that should bother you too. We hate fractions. Let's get rid of them. So if we get rid of them, I don't want to say that this guy's missing both of those and this guy's missing both of those. That would create, you could do it that way, but it's going to create a big problem. So you've heard of teachers in the past saying, get the least common denominator. That's what we're doing, is we're getting the least common denominator so that our life will be easy. All right, so check this out. This can be factored. So this is the difference of squares. So this is x plus 1 times x minus 1, and you factor it. So now the way I taught this, I told you to look at this guy, just look at the bottom. What is this guy missing that they have? He's missing an x minus 1. What's he missing? He's missing an x plus 1. And what's he missing? Nothing. So from that, you get the common denominator. So what did I say? I said x plus 1 times x minus 1, x plus 1 times x minus 1, x plus 1 times x minus 1. So that's what we're going to multiply by. So we're going to multiply both sides by the common denominator. So I'm going to multiply this side by x plus 1. See, you should leave yourself space. This is not good what I'm doing. Shoving it into one space causes confusion. Over here, x plus 1 times x minus 1. I hope you guys can see that over 1. So over here, it straight out cancels. X plus 1 times x minus 1 on the top cancels with x plus 1 times x minus 1 on the bottom. So we end up with 2x times 1 is just 2x. So that turned out nice. Over here, we have to treat this as two separate problems. So your x plus 1 cancels, but you end up with 2 times x minus 1. So once again, cover this up. The x plus 1 cancels. So you end up with 2 times x minus 1, and then you distribute, so that would be a minus, and now you cover this up, the x minus 1's cancel, so you end up with 1 times x plus 1. So notice that minus, I put this in parentheses because you have to distribute. Now, this was the hardest step. Does anybody want me to redo it?
Yeah, if you don't mind, just so I can be sure.
Okay, this is a rational equation, and we are multiplying by the common denominator to eliminate fractions in the first step. So we're not getting a common denominator, we're eliminating the fractions in the first step. So can everybody see this over here? That the x plus 1 times x minus 1 is canceling with x plus 1 times x minus 1, and you get 2x times 1. Okay, does everybody see that? Please unmute yourself and tell me.
Yeah.
Yeah, I understand that.
Okay, cool. Okay, on this next part, you're going to cover this up. And you're going to treat this, you're multiplying two fractions here. So the two fractions you're multiplying, you can cross cancel the x plus 1, and you end up with 2 times the quantity x minus 1. Do you understand that?
Yeah, because you cancel out the ones on the bottom then, right?
I'm canceling the one on the x plus 1 on the bottom and x plus 1 on the top. So
Yeah.
I 2 times the quantity x minus 1. You guys see that? So then you cover this up. And the x minus 1 cancels. So when the x minus 1 cancels, you get negative 1 times x plus 1 left over. So in the first part, you're multiplying two fractions. In the second part, you're multiplying two fractions. Do you get it or not? Because I can show it one more way. I really don't want to, but I can show it one more way if you don't get it.
No, I get it.
Okay. So we distribute. So this would be 2x minus 2 minus x minus 1 equals 2x. Combine the like terms. 2x minus 1x is 1x. A negative and a negative is a negative, and you add. And now I'm going to subtract x from both sides to get 2 minus 1 is 1x. So your x is equal to negative 3. Now that's the B part. So the B part is a solution, and that's where the graph is crossing the x-axis at left 3, 0. And the A part is the excluded values. So what can x not be? X cannot be what?
Minus 1?
1 and negative 1.
Listening?
Oh.
What makes this 0? X cannot be what?
Negative 1 or 1.
Right. Negative 1 or 1. Right. Because -1 makes this 0 and +1 makes that 0. Cannot have a 0 in the denominator. Same thing over here, -1 and 1. There are no denominators in the rest of the problem. The denominators are looked at on the first step. Is that clear or no?
Yeah.
So to get rid of fractions on rational equations, you multiply by the common denominator in the first step to eliminate fractions. Okay, anything else with P7?
Can you do number 10?
Today I told you, you have to make sure you prepare for exams. I'm not going to be giving a bunch of retakes. I'm not going to, allow you to have preferential treatment over my other students. You need to prepare for the exam before, not after. So if you have any questions, make sure you meet with me. If you have any questions, those math wizard teams, they're open all the time. You can go and work with people at 7 o'clock. You can work in those wizard teams whenever you want. And most importantly, make sure you do the online problems, because that will help you to know how to write the answers and what the problems look like. Your problems look exactly like those online problems. So the question is, how many questions are you going to have? Well, there's 10 sections. So if I give 2 problems from each section, that's already 20 problems. So I'm not going to give you that many problems probably. So every section is 1 or 2 problems. Okay, anything else from P7? You had to solve absolute value equations. You had to solve quadratics by factoring, square root, completing the square of the quadratic formula. Yesterday, I didn't talk about the discriminant, but they're going to ask you about the discriminant. If you don't understand it, you need to ask me. The discriminant is b squared minus 4ac, and it tells you the nature of the roots. So it doesn't solve the problem for you, but it tells you, do you have 2 real solutions? Do you have 1 real solution, or do you have 2 imaginary solutions that are non-real? You were also given a section that said, use whatever method you want. So you want to use the most efficient method. And then finally, we looked at yesterday solving square root equations, where you have to, isolate the square. And when you square both sides, you have to check for extraneous solutions, because squaring both sides could cause you to create a bogus solution. So you're forced to check it. All right, last call. Does anybody want me to work a problem? You have today and Thursday to ask me. So I'm giving you plenty of time to ask me. You can meet with me after school. You can meet with me at night. You can work in groups. You can work, so I want you to prepare for this exam. I don't want to hear, oh, well, the exam, or, I don't know, I just messed up. Take it. No, you got to be ready for it. You take college classes, they're not going to let you do any retakes. So we might as well get used to real life here. Besides, retakes don't work. Students have the right idea, like, well, I'm going to study for it and take the retake and do better. Students don't do better on retakes the majority of the time. They do worse. Trust me, I taught for 30 years. I've given retakes. I've allowed late work. I've done everything to help students. Those things don't work. All that does is enable students to be lazy and enable students to fail, because it's not holding students accountable on a daily basis. So I've already tried those things. Okay, last call. Does anybody want to ask me about any of these problems in P7 today?
Can you do
Yeah.
problem 83?
Okay, let's go with Brandon first. 83?
Mm-hmm.
All right, this is one you should know how to do. Okay, so you have x squared minus 4x minus 5. Okay, that is set equal to 0. This is a quadratic, and it's like, what do they want? What do they want from us? So they're saying compute the discriminant. So right away, you're going to write down the discriminant. The discriminant is what's under the radical of the quadratic formula. Remember, x is equal to negative b plus or minus square root b squared minus 4ac. So this is pretty simple. Your a is 1. This has to be set equal to 0. You cannot do this if it's not set equal to 0. So your a is 1, your b is negative 4, and your c is negative 5. Just plug them in. So b is negative 4, and you're not going to write it like that. You have to put it in parentheses. Remember, outside is going to be negative 16, and negative inside is going to be a positive 16. Don't mess it up now. Minus 4 times. So a is 1, c is negative 5, and here we go. A negative times a negative is a positive 16. A negative times a negative is a positive 20. So if the discriminant is, and this means nothing, by the way, this 36 means nothing. If the discriminant is positive, look what it says. It says, what does the discriminant indicate about the number and type of solutions? A positive means 2 real solutions. We do not know what they are, but we know that there's 2 real solutions. The discriminant, if you want to write this down, is on page 101. So if the discriminant's positive, there's 2 real solutions. If the discriminant is 0, it means that the parabola is sitting on the x-axis, and it means 1 real solution. And if it's negative, it means the parabola is not crossing the x-axis, which means no real solutions.
Wait, Ms. Birch, can you repeat what you said before the negative?
Yeah, let me write it down.
The one solution.
Yeah. Let me write it down. Okay. If the discriminant is positive, right? So if the discriminant's positive, there's 2 real solutions. If the discriminant is equal to 0, there's 1 real solution. If the discriminant is negative, there's no real solutions. And what that means, there's 2 imaginary solutions, which you can't see in the Cartesian coordinate plane. Now, the first graph means that the parabola is crossing the x-axis twice. The second one means the parabola is sitting on the x-axis for 1 solution, and the third one means that the parabola is not crossing the x-axis at all, no solutions. So this is the easiest thing we've done. So the discriminant is b squared minus 4ac. You set it equal to 0, put it in standard form, and see what you get. You get a positive, 2 real solutions. 0, 1 real solution. And negative, no real solutions. Okay, do you want me to do another one of those?
Yeah.
I'll do 88. Okay, 88 is 3x squared equals 2x minus 1. I've seen students before do this. Oh, wait, B is 2, C is no, it's not. You have to set it equal to 0 to get A, B, and C. You can't just look at that and say A, B, C, there it is. So you have to subtract 2x from both sides. You have to add 1 to both sides. So you get 3x squared minus 2x plus 1 in standard form. So now we know that A is equal to 3, B is equal to negative 2, C is equal to 1. Find the discriminant. B squared minus 4AC without the radical. So once again, your B is negative. Make sure you put it in parentheses. So this would be negative 2 quantity squared minus 4 times 3 times 1. So the negative squared is a positive 4, and negative times positives is negative 12. And look at this, negative 8. Well, that doesn't mean anything. It just tells us the nature of the roots. So since it's negative, it means there's no real solutions. And what it does mean, if we did this problem, if we solve this problem, there would be 2 imaginary solutions, but no real ones. And this means that the quadratic equation is not crossing the x-axis. This is pretty simple. Got some new furniture, and this black marker is getting all over everything. So I have some stuff covered up. Okay, anything else? Somebody chimed in before I did this problem. Anybody
Yeah.
else?
I have a question of the absolute value one for 47, if you could go over that.
Sure. Okay, 47. 2 times the absolute value minus 2 is equal to 14. So like I said, I look at this and go, okay, what do I have? What is this? It's absolute value. So what? You isolate the absolute value and you write a disjunction, which is an OR, right? So this is not isolated. He has a friend hanging outside the door. So to isolate it, you have to divide by 2. So you get the absolute value of 3x minus 2 is equal to 7. Okay, now you write the disjunction. So you're going to write an OR. The first one is 3x minus 2 equals 7. And the other one is the negative case. And I told you that you don't have to write this. You could go straight to 3x minus 2 equals negative 7. So when you solve this and you add 2 to both sides, you get 3x equals 9 divided by 3, x equals 3. Over here, when you add 2, you get 3x is equal to negative 5. So when you divide by 3, you get x is equal to negative 5/3. So your 2 answers are negative 5/3 and 3.
First step.
47. I'm just checking the answer real quick. So small, I can't even see it. I think it's negative 2/3. Negative, is it negative 5? Yeah, I think it's right. Okay, what's that again?
First step. Go again.
This 2 is in the problem, and I divided by 2 to isolate the absolute value. So this 2 is being multiplied to the absolute value. So this is 2 times the absolute value of 3x minus 2.
Okay.
So remember we have to isolate the absolute value. So I'm dividing both sides by 2 to isolate the absolute value.
Okay, I get it. Yeah.
So just remember that in these higher level math classes, you can't just know how to do the problems. You have to know the approaches. Like, okay, absolute value equation, what do I do? You isolate the absolute value. You write a disjunction, right? Which is an or, to get rid of the bars. So absolute value means a compound sentence, and compound means that there's 2 parts. All right, anything else? So yeah, see, your whole life in math, the teachers just gave you 10 of the problems look exactly the same. Easy. In Algebra 1, they gave you 1 objective. Right now, I'm giving you 12 objectives. And I'm giving you 60 problems that are all different. So that's what you haven't had to do in the past. You haven't had to, you've done the problems, but you haven't had to say, okay, it's a radical equation. What do I do? It's an absolute value equation. What do I do? It's a linear equation. What do I do? It's a rational equation. What do I do? So there's this added thing that you've never had to do before, and that's study. Because if you don't know how to approach a problem, you can't do it. So you have to be able to look at the problem and go, what kind of problem is this? What do I do? What kind of problem is that? What do I do? So there's an additional thing that's being added to, the past classes were easy, 10 of the same problem, didn't have to study, you just do them all the same way. So this is why this class is challenging, because you've never had to study before. A lot of you don't know how to study in a math class. You have to make index cards. You have to test yourself. Like on the card, if it says absolute value equation, write it on the back. You isolate the absolute value. You write the disjunction, right? Square root equation on the back. What do? You isolate the square root. You square both sides. You have to check for extraneous solutions. Solve by factoring. What do? Set it equal to 0. Put it in standard form. Factor. Use the zero product property. Okay, anything else right now? Okay, well, I'll ask again tomorrow, but for now, what I want to do is I want to start on these word problems, and here's the good news. I'm not assigning all of them. What I'm assigning, I'm doing the even ones, and I want you to do the odds. So for example, if I do number 14, you're going to do number 13. If I do number 42, you're going to do 41. If I do 53, you're going to do 52.
And this is for P8?
Yeah, this is P8.
Okay.
It's all solving. I mean, it's all practical problems. All right, so let me just give you some notes before we get started to know how to approach word problems. And I think you've heard me say I was never good at word problems. So I'm going to be able to teach this to you really good because I never understood it. So
I think I'll be good by here because I did like the 80s on this one. But I'm only doing 4 problems. It's just like I don't do the hardest problems. I literally only sound like the easiest ones. So.
okay. Good. Okay, there's only one objective, and it is to use equations to solve problems. So I want to write down the strategy that we're going to take. So number 1, you're going to read the problem a few times. Now, I don't know about you, but I'm not a good reader. I'm the type of person where when I read a book, I stop for a minute and go, what have I been doing for the last half hour? I don't even remember a thing I was reading. I was like daydreaming while I was reading or something. And I've always been like that. Like, what did I just read? I have no idea. So I have to go back and read it again. And when I go back and read it again, I do the same exact thing. I'm thinking about something else and I have no idea what I read. So you might have to read the problem a few times. And unlike English, where you're reading like a love story, you're not getting a feeling about the characters. In math, the words mean something. Like more means add, decrease means subtract, is means equals, result means equal, quotient means divide. So the words mean something. So it's almost like you're translating English into math. Now, you're going to let X be the unknown. Like, for example, if they ask a question like, how fast did the dog run down the street? How fast the dog ran down the street. If they say, how many marbles are in the jar? M is going to be the number of marbles in the jar. You know, how far did the football player kick the ball? K is going to be how far the football player kicked the ball. So the variable X is the unknown. So it's going to, so X is going to represent the question. Or what they want you to find. All right, number 2. You're going to write expressions for parts of the problem. And those expressions could be a part of the equation, but we're just going to write them down to see if they're going to help us. So you're going to write expressions for the problem. The third step is you're going to write an equation. So from the expressions, we're going to write an equation that represents the problem. And then we're going to solve it. And then we're going to answer the question in English. So we're going to, because people aren't going to understand math. So you have to answer the question for people to understand it. And number 6, we're just going to think about it and see if it makes sense. And what I mean by that is, let's say they're asking you how fast you drove on the freeway and you get negative 55. Well, speed can't be negative, so you know something's wrong. You know,
Miss Chris, can you put it down real quick for me?
if they ask, well, how hot is it outside? And you get a temperature of negative 106. Well, that's not even going to happen in the coldest part of the world. So it doesn't make sense, especially in California. All right, so we're going to read the problem. We're going to write expressions that represent the problem. We're going to write an equation. We're going to solve it. We're going to answer it so people can understand it. And then we're going to check to make sure that the answer makes sense. And like I said, I'm going to work the even problems, and your odd problems are going to match up. Okay, so here's my last bit of advice. Draw a picture. So we're going to want to draw a picture if possible, because that will always make our life easier. And you're going to want to label X in the drawing.
Ms. Birch, can you move your camera up?
So we're going to draw a picture if possible, and we're going to label X in the drawing. Okay, do you guys have this written down so I can erase it? Hello?
Yeah.
Okay. So open up your book to page 122. Now, some of these you're going to want to use in real life. Like when you go shopping and you want to know the discount of things, you don't have to sit there and go, well, I wonder how much that is off. You know, you're going to be able to use this to help you find discounts or tax. When you buy big items like televisions, stereos, they have tax, and it can be hundreds of dollars worth of tax. So it might put you over your budget. All right, so I'm going to work a variety of different problems. So I have my book. Take a look at problem number 2. Now, like I said, you might have to read this 10, 12, 20 times. Okay, you see the graph there? See the graph that says, how will you spend your average life expectancy of 78 years? And in that graph, they have sleeping, working, watching TV, doing housework, eating, socializing, and shopping. Mine would be, my biggest one would be shopping, and the littlest one would be sleeping. They'd be switched. And this graph is given by the U.S. Bureau of Labor Statistics. And what's important about this graph, or any bar graph, is the title and how the axes are labeled. So the x-axis is labeled, well, that's going to be what numbers, I think. They didn't label it. That's not good. You always want to label the x-axis. The y-axis is the average number of years. So average number of years. And I guess the x-axis should be labeled different things you do, like sleeping, working. That's what the x-axis is labeled as. Different things you could do throughout the day. How's that? So number 2, it says, according to the American Bureau of Labor Statistics, you will devote 32 years to sleeping and eating. The number of years sleeping will exceed the number of years eating by 24. Over your lifetime, how many years will you spend on each of these activities? Now, like I said, when I read that, it's already left my mind. I don't even know what I read. So I'm going to have to look at it again and again and again. What are they asking for? So first of all, we can look at the question. They say, over your lifetime, how many years will you spend eating and sleeping?
By 32 years?
Yeah. Yep. Well, yeah. Yeah, you will devote 32 years, right. But here's the deal though. So here's what we want to do. We want to let X equal one of them. So we'll let X equal the number of years eating. Because we don't know that. See, we can look at the graph, but we don't know exactly. If we let X be this, and they say that, then, okay, so X is that would mean that X plus 24 represents the number of years sleeping. Because of what the writing's saying. See what it says? It says that the number of years sleeping will exceed the number of years eating by 24. So here's what I used to do in high school. I would let Y equal the number of years sleeping. Well, guess what? You can't do that with two unknowns. So what we're doing is we don't know what the number of years eating is, and we're representing the number of years sleeping using the number of years eating. Because the writing says that the number of years sleeping is 24 more than the years eating. Okay, are you guys with me? So this is where I made my mistake, is I didn't describe this guy in terms of X. I threw in another variable, which is not a good idea. That's why I could never get the right answers. All right, so what we're going to do now is it says that the total of these guys, so here's the deal. What I realized is write an English statement. So write an English statement. So didn't they say that the number of years eating plus sleeping equals 32? Didn't they say that? So I know this is weird, but I understand it, and you probably will too. So now we put in the actual math. So the number of years eating we said was X, and the number of years sleeping we said was X plus 24. Well, look at that. Can't we find X? And if we find X, are we going to get the answer for the number of years eating? And if we get X, can we plug it in here and get the number of years sleeping? So X plus X, 1X plus 1X is 2X, plus 24 equals 32. Subtract 24. 2X is equal to what, 8? And X is equal to 4. So I'm just going to plug this in really quick. For eating, we have X, so that would be 4. For sleeping, we know that's X plus 24, so that would be 4 plus 24 is 8. Now remember what I said? We have to make a statement that makes sense to human beings. So now we're going to make a statement because we understand what. And so this right here is for the human race. All right, we're going to say that Americans will spend 4 years eating. Americans will spend 4 years eating and 8 years sleeping.
Miss Birch, I don't mean to bug, but could you go up a little bit? I'm sorry.
So we solved this algebraically by writing an equation. So these are the expressions up here that I was explaining. So we read the problem. We wrote expressions. We wrote an equation. We solved it. And this does make sense. So we read the problem, we wrote expressions, we wrote an equation, we solved the equation, we answered the question, and it made sense. So that's the key thing, you guys. You're going to see me defining an unknown and writing expressions based on the unknown. Don't throw in another variable like I used to. Okay, now with this, you guys.
So how we got the 4 was we divided the 2 by the 8?
Divide by 2, divide by 2, right?
Yeah. So that's how, okay, so x equals 4, okay.
Solving an equation. So how do you get rid of 2? Divide by 2, divide by 2. Okay, so with this, you should be able to do number 1. All right, now I'm going to do number 4, which is going to allow you to do number 3.
Ms. Birch, it's already 10:16.
It's already time?
Mm-hmm.
Oh my gosh, you guys are so cute. Thank you for being patient. I'm sorry, you guys. Yeah, thank you for letting me know. You guys have a good day, okay? Have a good day. I'll see you tomorrow. Bye, you guys. Have a good day. Have a good day. Bye.